Hello. So we are back, but this time let's learn about the transistors, okay? So I'll make sure on the end of this video you will know exactly how a transistor works, yeah? And also let's make some money, yeah? Let's build something which we can sell. If you are looking for a 10 minutes video, this it will not be a 10 minutes video, yeah? This it will be all about explaining you how you can design, how you can read a schematic, how a transistor works, how we can design a circuit using a transistor and a logical approach according with Ohm law. Okay, great. First, I'm very excited when it's about DIY and building things and transistors, special the transistors. Yeah, I'm coming from an age where we work a lot with transistor and also valves, but valves not that much, but transistors. I learned electronics on that age. Yeah, we didn't have actually chips, only transistors, and it's a feeling. It's like going back to the childhood, playing with transistors. Okay, so let's quickly just go like quickly a little bit of theory, yeah, just a little bit, not too much. Then let's design a circuit with a transistor spinning around his tail. You know that thingy? So you can make a transistor to spin around his tail, and I will teach you that. Yeah. So quickly, let's go through the theory. Now, first, the symbol of a transistor. Yeah, we are speaking of B-junction transistors. Yeah. So we have that's the symbol of the transistors. If the arrow is pointed out, this is a NPN transistor. That means it has two junctions, N and one P. Okay. The other transistor you can find is with the arrow pointed inside. This is a PNP transistor. Yeah. So what's the difference between a PNP and NPN? The difference is the current is flowing on a different direction. Now let's go back to the first one. We can build like a simple circuit, like a very simple one. Very simple one. So let's say we have a transistor. Yeah. We have a light bulb. That's the symbol of the light bulb. And then here we have our power supply. Plus. And here we have the emitter with the NPN transistor. And here we have ground. Okay. Ground, which is also minus. Okay. Let's work with 12 volts. 12 volts. That's plus, that's minus. So the pins of the transistor is emitter, collector, and base. Now, I seen on the other video when I spoke about the Ohm law and things, and the people said, or on that one, on a different one. Sorry, I was thinking the current is flowing from the minus to plus or from the plus to minus. So in which direction actually the current flow on a circuit? And the answer is, the simple answer is doesn't matter. Yeah. So this it will mess up with your brain, and it's not important how the current flow on a circuit. It's about how you see that current flowing on a schematic on a circuit. Yeah. Actually, the electrons are flowing from the minus to plus, and the current from the plus to minus. It will mess up with your brain. Yeah. You can't learn on that way. So we always looking at a schematic, yeah, always looking at a schematic with this direction, yeah, from plus to minus, yeah. So you want to test or read a schematic, you read, okay, from plus, I have a light bulb, okay, the light bulb has few dozen of ohms or ohms, yeah. And here, what do I have? Probably here I have again 12 volts if the transistor is not driving the power. Now the transistor, it's exactly a switch, it's nothing else. I explained it so many times on the MOSFET. Now the transistor, let's draw here one. Yeah, and you have the base and you have the emitter one more time. It's nothing more than a relay, yeah? I mean, at the first look, it's nothing more than a relay. Okay, and on a relay you have this coil. When you apply power to this coil, this contact, it will get close and it will drive the current, right? Okay, remember we spoke on the last video about resistor, and actually a resistor doesn't lose the voltage and actually the current, and losing the current actually is losing the voltage. Now I want to forget about thinking about currents when you are reading a schematic, yeah? So always think about the voltage. Now let's build up this schematic, okay? Just to see the difference between a relay and a transistor. A relay is an on-off switch, okay? This can be only on or off. The transistor, it's adjustable however you want. So the only condition, yeah, for this transistor, it's about the voltage applied from the between the emitter and the base. That's all what is important. So let's say here the transistor is opened by current, but I don't want to keep this in mind. I want to forget about the current, like how I said. It's always about the voltage, yeah? So keep in mind the transistor, it will be like a switch. It will drive the max power when it will have 0.6 volts. Okay? Forget about the current. You are not. I will. If I read a schematic with transistor, I never think like 1 second about the current. No, think about the voltage. If I'm testing a board with a transistor, I'm thinking about the voltage. I want to see between base and emitter 0.6 volts. If 0.6 volts means that from the base to the emitter, it's going like 20 microamps. I don't care about that. It's all about the voltage. I want to see 0.6 volts. If I have 0.6 volts, I know for sure the transistor has the right current to drive the power from the collector to the emitter. Okay? Good. So, let's build quickly this schematic. Okay? So let's pick up a transistor. Which one? Let's go for a good one. A good one. BD239C. This is an NPN transistor. It's a nice one. This can carry a lot of current. So the difference between the transistor is about how much current can carry. Like the small one, it doesn't carry that much. The big one, it will carry more. The other difference is the amplification factor, which is higher on the small one. But we'll speak later about the amplification. First of all, how do you check a transistor? We don't know which is base, collector, and emitter. Very simple. Let's get a multimeter. The multimeter is on screen, yeah? So base, it's always common, yeah? The transistor, you can okay, it's the same. A transistor is the same with this configuration, yeah? So check here. 2 diodes, yeah? 1 diode here and 1 diode here. That's the equivalent schematic of a transistor. So logical speaking, if one probe is on base, okay, obviously you can check the emitter and the collector and you can check the both junction, yeah? Never from collector to emitter you should have a reading. Yeah, if you have a reading, that means the transistor is faulty. But always you should have a reading from the base to both collector and emitter. And we are speaking about B junction transistor. It will be another video about MOSFETs. Okay, so let's check those transistors. So we don't know which pin are. You'll find a lot of transistors with different pins. So we have no idea. Let me switch. Oh, it is. It is now. It is on dial now. So those first pins. Can I make this? No, it's max zoom. From here to here, nothing. From here to here, nothing. No reading. You can see this meter, with the diode. So I have no reading from here to here and from here to here. And already I can assume one is collector, one is emitter. Now the base, from the base, here, nothing. Oh, sorry. Here, 0.6, same reading like a normal diode. And from here to here, 0.6, same like a normal diode. So this transistor is good because I have from base to collector, yeah, and from base to the emitter. So on this transistor, the base is on one side. Most likely always you'll find the transistors like this with the base on one side, the collector to be on the middle, okay? So we know this is the base, we know this is the collector, we know this is the emitter, and we know the transistor is good. Now quickly, let's build our, so we know base, collector, and emitter. Okay, so on the collector, we will go connect the light bulb. Okay, this is our schematic. We have the transistor, the collector is connected to a light bulb, and from the light bulb is going to the plus. The red probe is plus. Red is most likely always plus. The emitter is connected straight to the ground. Yeah. So our schematic is it's exactly like on the screen. Yeah. Like here. Okay. So we build this schematic. Now, just to understand, yeah, it's about, okay, what voltage it will be here. Yeah. That's what I want to know. What voltage it will be here. This is something else. Yeah. What voltage it will be here. Now you'll say, sorry, the emitter is connected to the ground. So you always check the voltages compared with the ground. So with the ground, here is the emitter which is connected to the ground, we have 0 volts. But what do we have on the collector? On the collector we have the light bulb. The light bulb is a resistor, so I expect from 12 volts, I should have here on the collector 12 volts if the transistor is not driving the current. Yeah. What will happen when this transistor it will switch? Yeah. So we have here the switch. Yeah. What will happen if this transistor it will drive the power? My ground from the emitter it will move here. It will move here on the collector. So if I will have ground here, I have the light bulb. Here I have plus. The light bulb it will light up. Okay. Like how I said, the transistor is like a switch, and that's how I want to see it, like a switch. The only condition for this switch to be open from the collector to the emitter, it's about the voltage from between the base and the emitter, which has to be 0.6 volts, right? Now let's try a few things, yeah? So the emitter connected to the ground. From emitter to collector, we have, check on the screen, 12 volts, okay? So we have 12 volts. Now, in order to click this transistor, we can simply short those wires, yeah, the wire from the ground and the wire from the bulb, yeah. So I can short them, and I can make the light bulb light, yeah. Now, like how I said, we can come with the 0.6 volts and open this transistor, okay. So how we can get 0.6 volts? So that means we need another power supply. The 0.6 volts with the plus here and the minus here, okay? Very simple and very easy. We can use a resistor. We can use a resistor from here to the plus, yeah? Very simple. From here to here. Or even better, yeah? Let's try something else. Let's come with a adjustable resistor, yeah, like that. adjustable resistor, yeah, and one end of the adjustable resistor we are connecting to the plus, and the other end of the adjustable resistor will connect to minus. You see, that's the reason I told you always to read the schematic, or yes, to read a schematic from the plus, because on the plus you have less connections compared to the ground. So just thinking, okay, so my voltage is going here and it's going here, and it will mess up with your brain. Always from plus, yeah. So we know one current is going here, yeah, or the voltage. The voltage is going here and is going here, okay. Now the resistor, it will give us the opportunity to adjust, yeah, this voltage on the base. And when I'm saying that voltage, what does it mean? Does mean from 0 volts to 0.6 volts. Okay. Now it's more simple indeed to see a transistor as a switch, but this transistor has a adjustable internal resistance. Okay. So basically playing from 0 to 0.6 volts, actually you play with the resistors between the collector and emitter. So this switch would be, it will be adjustable. So how I'm seeing a transistor, it's same like a resistor, adjustable resistors with very low ohms. Yeah, so from like 0.5 ohms, yeah, for a B-junction transistor, up to infinite ohms, depends on the 0.6. Okay, so let's add adjustable resistor and see what will happen. Okay, so this is an adjustable resistor, and it's nothing else than a resistor with a metal thing which is spinning around the resistor. Yeah, it's an adjustable resistor. So how we can connect this here? Yeah, just a simple design. Okay, now we have connected the resistor, the adjustable resistor, yeah, and according with schematic, yeah, on the base, yeah, from the plus and from the minus, from the ground, yeah, according with the schematic, with this one, yeah. So one from the plus, one from the minus, and one to the base, yeah, the adjustable point to the base. That means this base, yeah, this pin from the adjustable resistor should move from the plus 12 to 0, right? Okay. Now let's check together to understand. I will take the multimeter just to check the voltage between the base and emitter, yeah? So the base of the transistor, which is this one, to the emitter, and we have 0 volts, okay? Now let's adjust this resistor. Let's see what will gonna happen. And as you can see, or you can't, sorry, I can easily adjust and set up any output voltage from this resistor. Now let's check the voltage between the base and the emitter. Emitter and base. We have 0.6, you can see on the screen. Okay, let's make it less brighter. Yeah, like that. Now let's check the voltage again. Base and emitter, and we have 0.5. That's how you adjust the voltage, yeah? That's how you make a transistor to carry or to drive a load. What do I want you to understand is just triggering the transistor, yeah, only from the base, yeah, with a small current, actually microamps. We can drive a light bulb which is taking a lot more power. Like on this one, let's see on the power supply, And this light bulb is taking 800 milliamps, you can see. This is called amplification, okay? So with a small current on the base, we can get a lot of output from the collector and emitter, okay? So the transistor, what you see here, this is just adjustable resistance resistor from the collector to the emitter, yeah? That's all. That's what it is. That is what is a transistor, no matter even a MOSFET or a FET, any transistor. It's a just variable resistance between the collector and emitter. So all the today electronics is built on this design. And the inside of the chips, there are thousand, hundred, thousand, millions of those kind of transistors. Okay? Hopefully you learn how a transistor works. Now, what do I want to speak is how do you make a transistor to spin around his own tail? Yeah? Anyone knows? You can make the transistor to spin around his tail. First, you have to understand, like right now, the transistor is getting quite hot. I mean, if I'm making to, yeah, it's drawing 800 milliamps, yeah? 800 milliamps, it will get the transistor hot. I want to replace this light bulb with a relay. So what do you think? We can do it? So replacing with a relay, we will have a on-off switch, yeah? This will be only on-off. We need a relay just to make the transistor spin around his own tail, yeah? So let's do it. So what do we have here? Here we have a relay, yeah? And a relay, you have a coil and you have contacts, yeah? So it's an electromagnet with contacts. So you apply voltage and it's clicking and it's touching two contacts there, yeah? This is like 15 amps. So with a small input, probably a few milliamps on the coil, we can trigger up to 15 amps, yeah? Which is beautiful. The relay, it's a very nice thing, yeah? But the disadvantage is this doesn't amplify anything. This is just a simple on-off device. Okay, so it's all done. We insert the relay. Let's draw the schematic quickly. New schematic, so we have the transistor. Ground, emitter, the collector, and the collector is on the relay, yeah? Okay? Then we have the contact of the relay. Okay, so this one is going to the light bulb, and from here is going to plus. Plus 12 volts. Now the minus is going to the ground. Okay, on the base we still have the resistor, the adjustable resistor. Okay, so that's our schematic. So what do we know? When we will have here probably around 0.6, yeah, 0.6 volts, what will happen? Yeah, the transistor, it will drive the power. If the transistor will drive the current, yeah, or let's say the transistor, it will connect this coil, yeah, this is the relay. If the transistor, it will connect this coil to ground, what will happen? The relay, it will click and it will light the bulb, yeah. So we will have, what do we have here? We have this flow, okay, then down to ground, and here we have here, we can have here, and also we have one to the adjustable resistor. Okay, so it's very simple what's going on here. Instead of the light bulb, we connect the relay. Relay, it's a 15 amps one, so here I can connect big light bulbs, yeah. You can also connect like mains lights. So if I disconnect the ground, I disconnect the light bulb, and if I take these two contacts and I connect them to mains with 220 volts, I can light up like a normal light bulb. Now, the schematic is quite simple, right? So we have the transistor, we have the same resistor. From the resistor 1 connected to plus. Then we have the collector, yeah, and the collector, we connect the collector to the relay coil, yeah, relay coil. Here is the other end of the relay coil, which is going to plus. Now the ground, yeah, we have one ground from the resistor, we have one ground from the emitter of the transistor, and we have one ground for the light bulb. Yeah, you remember the schematic? We have like a switch between the ground, yeah, and the light bulb here. So when the relay will click, we will have something like that. Yeah. Okay. Now let's click the relay. Clicking the relay does mean spinning this. Yeah. All done. Now let's check the voltage. I don't think you can hear. But okay. Cool. Now let's see and check the voltage. So same story like before, base and emitter, we have 0.7. Yeah, so the voltage is quite high. We don't need that much voltage because you can click the relay under 12 volts, so it's okay. But we have a working schematic. Now to make the transistor spin around his tail, it's kind of simple, yeah. Let's try and design this on the schematic. So we know when we have here voltage, the relay will click and it will light up the bulb, yeah. But let's do something else. Let's take the voltage, yeah, this voltage. Here we have 12 volts, it's connected to 12 volts, yeah. If we are taking this voltage from here, yeah, just pay attention because this is tricky. It can mess up your brain. So we are taking this voltage, instead of taking from here, we are taking from here. You remember we check. So if the light bulb is off, here we will have 12 volts, right? When the relay is clicked, Here will be 0 volts and here will be 12, right? Good. It's what will happen, because what will happen, it will be very fast. So if we are taking the voltage from here and we are switching, yeah, we are setting up 0.6 volts on the transistor. So the transistor, it will drive the power down to ground, the relay. So the relay, it will click. When the relay, it will click, it will light up the light bulb, yeah? What will happen with the voltage here? Yeah, it will go to 0 volts. That means it will be no voltage on our base. That means the transistor, it will shut down the power, and the relay, it will declick, yeah? When that will happen, the voltage here, it will just jump up to 12 volts again. Having 12 volts, we will have back to the base 0.6 volts, and the relay, it will click again. And this, it will happen very fast. On that moment, the transistor, it will start spinning around his own tail, yeah? So basically, if we are giving on the base 0.6, what the transistor, it will do? Okay, let's drive the power, but on the same time, he will drive to his end, yeah? Because this, it will click and the voltage, it will goes away. Now, this is a loop. It's a very interesting loop. It will happen very fast, yeah? We're gonna try to slow down the transistor and making spin slower, but let's see what will happen, okay? Okay, so we connect the wire which was going before to the plus to this wire from the light bulb, okay? Now let's power on and see what will happen. The relay is moving. You can see it moving. So now the transistor is spinning extremely fast around his own tail, yeah? And the only limit on this one is actually the relay speed. The transistor can spin a lot more faster, like up to millions times per second, yeah? This can go up to few megahertz. But the relay is very slow. Now, how we can slow down the transistor? We can slow down. To slow down, you have to add a buffer. Yeah, we can add a simple buffer to slow down this process and make this more nicely. A buffer can be a battery. A battery is a good buffer, right? Charging, discharging. Or a capacitor. A capacitor is like a short time battery. A capacitor can slow down the transistor. Okay, so let's add a capacitor. So we are adding the capacitor. Where? We are adding a capacitor. Where do we add a capacitor? Let's see on the schematic. So we will be adding a capacitor B2 base, yeah, from here to the ground. Okay, so that's how we're gonna slow down the transistor. So let's do it. All done. Now let's power up the power supply. And I think we have to, no. So we just slow down the transistor, yeah, to spin slowly. So we have the capacitor, and the capacitor is like a buffer, okay? So you can see now it's clicking slower. But still we can change the speed. Yes, we can change. We can add a bigger capacitor, or we can adjust the resistor. And that's how you make a transistor to spin around his own tail. So what is this? This is a car blinker, or a motorcycle blinker, or a scooter, electric scooter blinker. This is something what you can sell and you can make money. When I was younger, I make a lot of money with blinkers. So even now, I'm pretty sure I can make this like you know, a nice board, designer board, and you can sell them on eBay. Actually, I'm buying like DIY electronics from eBay, and I bought, I think, a few months ago. Remember, I had the big power supply, and I modified the fan to spinning slower, and on the some point, I just go on eBay and I bought from someone a nice regulator for the fan, yeah, to have always a variable speed on the fan based on the temperature. So you can still make nice money just selling DIY electronics. So check here, check here. You see this one? So I bought this one few months ago. Was like 8.7 pound. The guy sold 350. You can 350 because you cannot buy regulators like fan regulators with like normal regulators based on the fan with two wires. Yeah, you can buy PWM. Yeah, but not like normal fans. Yeah, that's why these guys sold like 350. And this guy is, I think, is from Bulgaria. Yeah, from Bulgaria. It took like 1 week, and this arrived and were great. Yeah, it has a thermistor there, and I was adjusting. I think even now it's still inside of my power supply. But that's how you make money from the DIY electronics, like this one. Yeah, like how I told you. I'm just giving you an example. I'm buying like DIY electronics sometimes when I need something. Like I was there on that case. But this one, this is sellable. We can sell it, you know. These things get broken on motorcycles or scooters or cars. So you can sell something like that. This is dodgy. I mean, it's not dodgy. This is like how I said, you know, you made a transistor to spin around his own tail. But the proper way to build this is with two transistors. I found that. I'm not sure of the English name of this. The flip-flop. Flip-flop circuit? Yeah, flip-flop. You remove the LED and you just use one, and or you can use the relay instead of the LED. That's the proper way to build this kind of... But even this one is okay. I can't see anything wrong with this one. Nothing wrong. Okay? So that's how you make a transistor to spin around his own tail. Or you can make like some nice, you know, light for your music, for your stereo. Like how I told you, remember, you can connect actually a big light bulbs. I mean, you can optimize this schematic. You can optimize and use a resistor. Instead of this wire, use a resistor, and you'll have a wider range to adjust the light bulb. It's quite nice, yeah. Just building something like that with one transistor, because that's the idea. So how this is working is it's happening very, very fast, very, very fast. But if we are slowing down, yeah, if we are slowing down this schematic, what is happening? Let me erase. Give me 1 second. So we delete this, yeah, we delete this one, and we add it. 1 second, yeah. We add this one. Yeah, I'll make a jump here. I'll make a jump. Yeah. We took the voltage from here. What is happening when the relay is switching to ground? The voltage here, it will be 0. Yeah. If it's 0, the transistor, it will not drive the power. That means the coil, it will not click this. It will not click this. Yeah. Or it will declick this. Yeah. If this is declicked, yeah, I mean it's not clicked, then here we will have 12 volts. The 12 volts, it will give us 0.6 to between the base and the emitter. The transistor is to start driving the power, yeah, having like 0 ohms, and it will connect the coil to ground. Yeah. When the coil is connected to ground, it will click. When the relay, it will click. Here I will have ground, yeah, right? So here it will not be 12 volts anymore. Then the light bulb, it will light up. That means if I have here 0, here I will not have 0.6. So all what the capacitor is doing, it's like a buffer, just slowing down the charge discharge cycle, yeah? Or it will hold the power, yeah. Let's say, okay, the relay is clicked, my voltage goes to 0. If I don't have the capacitor, the voltage it will goes to 0 instantly on the transistor base. But just because I have the capacitor, I can slow down this process, and the capacitor it will provide a little bit of current to the transistor for a short period of time. Yeah, in our case, probably like 1 second. That's how we slow down the process. Yeah. And on the other case, okay, the relay is declicking, so here I will have 12 volts. Then the voltage which it will reach the base, it will be slowed down by the capacitor, because on the first place, the capacitor has to charge. Yeah, so before providing voltage to the base, you will have one current here to the capacitor, and one to the transistor base, and also from the capacitor to the base. It's quite simple, you know. The capacitor is nothing else like than a very small battery. That's how I want to see a capacitor, and it will slowing down the transistor from the spinning, because he is spinning around his own tail. Okay, so I'll stop this video now. Hopefully you like it, enjoy it, and if you want to build something like that, you can do it. It's very pleasant to play, you know, to play with electronics, with transistors. Okay, thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.